Hello and Happy New Year. Hope you had good festivities. So today I'm going to be doing a live solve of Odd Region by Polman Poppins. And this has a really interesting rule set, so I will make sure I go over that carefully. So first of all, we do have normal Sudoku rules. Also, all odd numbers lie in a single orthogonally connected region. So we should be able to draw some kind of region out of all the odd numbers. And if we had this, we couldn't then have like a region over here of odd numbers that didn't orthogonally connect to this region. So we're gonna have to draw that. I'll highlight that all in orange. And it's every odd number, so we got to be able to reach every odd number. Numbers in circles, so that would be these, including ones where we don't know the number yet, they indicate the total count of cells of the same parity, either even or odd. So in this case, this would be odd. In this case, we don't know the parity yet. So it's the number of circles. The number of circles of the same parity, either even or odd, connected vertically and horizontally to the numbered cell, including itself. So for this 3, for example, I could do something like this, have all 3 odds like this, but then so let me just highlight here. So if these 3 were odd, then these 3 would have to be even in order to not increase this number beyond 3. Or alternatively, I could do like this, where I have 1 to the right and 1 above, but then this one, and this one would have to be even to cut that off. And let's pick a bigger one. So this 7 here, we could have like 1, 2, 3, 4, 5, 6, 7, for example. And then we have an even number here, but we'd have to have an even number here to cut that off, to make sure we don't get higher than 7. And so again, for these, they could be even or odd. Looks like we're only given odd ones, as far as I can tell. But for these 3, they could be even or odd, and they follow the same rule. And then we also have diamonds with numbers in them. And it looks like all the diamonds have given numbers. And they're the number of orthogonally connected even numbers, including itself. So if I have this 4 here, I could orthogonally connect 4 squares like this. And again, in the case of the diamonds, it doesn't have to see vertically or horizontally, it just has to be connected. But then I'd have to make sure that's walled off by oranges, or by odd numbers, that is. All right, so those are the rules. If you would like to try it yourself, there's a link below to the puzzle, and you can try it. And I am going to get started. So let's see here. I like to start this by, like any parity puzzle, I like to start just by highlighting all the evens and odds, and I'll use blue for even and orange for odd. We don't know those circles yet because they could be even or odd. And so now let's see what we see. So we need to make sure we don't cut off, say, the oranges from each other, because they all have to be connected. Let's see if that means anything yet. Do we have to come through here? I mean, we could technically come up here and around here and completely avoid the center. Something like that, but it's likely we're gonna have to come through, but I don't know that for sure yet. So this one sees 5 this way, and this one sees 7. So we have to have at least 2 vertically. That doesn't necessarily mean anything yet. This one sees 5. It can have up to 3 here, so it needs to see at least 2 vertically. And it sees, okay, how about this? It can see 1, including itself. I need to be careful, including itself. So 1, 2, 3, 4, 5. So it could just take this line. What about, so we could only have 4 evens in our box here. So however we have those 4 evens, we need to have 4 more connected outward. But again, that's not Not seeing immediately how to use that. Okay, this 2 means there's only one even out of these 3. Again, not seeing immediately which ones those have to be. It's probably these 2. Or sorry, it's probably one of these 2. See, the evens don't have to be orthogonally connected, so we don't have to like avoid checkerboards or anything. Well, okay, if it were like this, maybe this checkerboard is bad. So could I get 8, 1, 2, 3, 4, 5, 6, 7, 8? I could do something like that and then connect all the way around like that. So that is just possible. So checkerboard's fine. Wow, having trouble starting. Is there any Sudoku to do? I haven't actually looked. There's a 2 in these 2. 3 and, oh, we can place a 3, so that's odd. Got so hung up on trying to draw blobs that I didn't look at Sudoku. 5s and, okay, so there's a 5 here. Basically given. So that's also odd. So that's a circle. So it's got to see, so it already sees 1, 2. So it needs to see 3 more odds. That could really be anything. Interestingly, if all 5 were this way, then the rest would have to be even on this row. It's the same here. If these were all odd, then these 3 would have to be even. That seems possible. If these were odd, these would be even. That also seems doable. Okay, any other Sudoku? 5's looking in here, so there's a 5 in one of these 2. 8's. 8's one of these 3. 4's looking here. I'm not going to mark that. Four is one of these 3. Maybe I should mark those. Where was that other 4? Here? Oh, it was here. It's good to know where evens might be. 3 looks into here. One of these is 3. That's not so exciting. 3 is one of these. Okay, I think that's probably all the Sudoku. How do we do on 3's? Okay, 3 is up here. Okay, so what does this tell us? This has to come out, right? Because we can't put 2 evens here or this will get isolated. So at least one of these is an odd. They could both be odd because this 3 just means, but if they were both odd, let's see, if they were both odd, then these 3 would have to be even. Which seems okay. It means we only get one more here. So 2 out of these 3 are even. I keep getting these like almost fill-ins. I don't even know how to mark that one of these is odd. So I guess I won't. Okay, this 5. I guess I was going to say we can't make all 5 of these odd, but that's obvious. We could do that, for example. Only one of these is even. So this 3 already sees 2, so it only gets 1. So again, only one of these is odd. One of these is odd. Okay, so however this comes out, so if it came out this way, we'd have to surround it in odds. And so that uses up the odds for the box. On the other hand, if we come out this way, we have to surround it in odds like that. So what's the overlap here? This is odd. Is that the only one in common? Yeah, here we'd have to, sorry, I guess we'd have to make, if it came here, we'd have to make these 2 odd. I think I drew way too much there. So let me just do that again. So if it were here, these 2 have to be odd, and this one has to be odd. But this one could be either, because it's no longer orthogonally connected. And if it's here, then these 2 have to be odd. So in common, they have this one. This one's always odd. It's not 5 or 7, so it's 1, 3, or 9. Anything else like that? This 4. I mean, it could, well, can it go 1, 2, 3? No, so I can't have it come all the way left. Like it come 2 left, but if it did a third, then we'd actually have 5 orthogonally connected evens. In fact, I can only have 3. Let's see, I guess I could do that. So it could be all in the box. Are there any it's forced to take? So it can only come left 2, but it could do that. It could do that. Yeah, there's no one cell that it must take. Oh boy. I know there's just something obvious that I'm missing. Go ahead and yell at your screen. Maybe I'll hear it. But this too. So if I took this one, then all 3 of these would be odd. Okay, if I took this one, I'd have to have too many odds, because it has to be closed off. See that? Any of these other ones were even, it would extend the blob, and then I have 6 odds in a box, which is obviously you can only have 5 odds in a box. So we've proven that one is odd. What if it came this way? We'd have to make those 3 odd. No, this one wouldn't have to be. These 2 would have to be odd. And that seems to work fine. So I get one more odd here, which is a 1, 5, or 9. One of these two is odd for sure, but we're not sure which. That's 3 odds in total. Could be 4. Okay. We're learning small things. Does this 8 have to grow in a certain direction? I mean, it seems like the 8s are not so useful. We just have to make sure we don't close them off when we're building our orthogonally connected odds. Does this affect any of the... Okay, so this 5 here, I should have seen this earlier. So even if it took both of these as odd, that would only be 4 that it sees. So it has to see at least one more, which means this is not a 2, which means the 2 is here, and that's even. This can't be 3, 5, or 7, so it's 1 or 9. Okay, I feel like I'm making a bit more progress now. We only get 2 more odds in here. We could take this corner still, it would be connected to here, and it can get out. Is it going to be difficult to fulfill this 7? 1, 2, 3, 4, 5. We could do that. Interestingly, we couldn't take, if we took all 5 of these, we couldn't take this one, because then we'd be seeing 6, but if we took, there's only one other place on one other cell to take, and that would give us 2 more odds. But we obviously don't have to take both of those. Given this 8 here and the 2 here, I'm imagining that we probably don't. But we can't guess like that. So is it possible for the evens in this box to not be part of this blob? Well, this blob here can grow with any of those cells. So the only cell it couldn't grow with is this one. But even if this one were even, any of the other, we have to have one more even in the box, and that would connect it up. So the 2 evens that are left in this box finish off this 4 diamond, which means this has to be odd. And it's a 1, 3, or 7. Wow, I feel like every little cell that I get is its own piece of logic. That's kind of fun, though. So we can only get 2 more odds for this 5. We have 2. We can only get 2 more from this box because we only get 2 more odds. So it has to take 1 more. And might as well fill this one as well. It's a 1, 3, or 9. So now this 5 sees 4. So it takes either this one or this one. If it took this one, that would force a 4 here. Which seems okay. One of these is odd for sure, because we need a 3. It can still be this one. Let's see if there's any other limitations here, because we need a 9 as well. This can't be the 9. So the 9 is somewhere here. Oh, no, wait, this could be the 9. We need a 1, 3, and 9. And the only limitation is 3 can't go here. So I wonder if I should focus elsewhere or try to keep growing this. I mean, I feel like this area is quote-unquote done. There's going to be 2 evens, which finish the 4 diamond, and there's going to be 2 odds. I guess, interestingly, these can't both be odd. So this is 3, 6, 8. Okay. Oh, but the 3 could be here. This could be like 9 with a 6, and then the 3 goes here. If the even were here, it would have to take... If the even were here, then this is odd. And one of these other ones would be even, forcing this one to be odd. So then this 5 would see... Yeah, I'm not sure what that tells me. This 3 gets 1 more. This odd has to connect up, but technically it could do that, right? And then this would connect here. So, I mean, it's likely that it connects up like this, but I can't assume that. If I could assume that, then that means this one has to be even. And then the other one of these two that isn't odd would have to be even. But I don't know how to prove, like, well, hold on, do we... If these 4 were odd, then we'd have to have evens like this, and then these 2 would be odd. That sees 5. That sees 4. I mean, that seems to work, actually. I can't immediately prove that wrong. How about this 7? 7 is seeing 4. It only gets 3 more. Okay, so yeah, I looked at this earlier. If this were odd, this has to be even. I explained that earlier. But I don't know if that means anything. Shoot. Okay. Is there anything else to look at? This 3? There's no guarantee about which way that goes. Same with this 3. Interestingly, having both of these odd... Well, okay, if both of these are odd... Oh, sorry, this 3 isn't a circle. Never mind. Can't say anything about that. That would put evens in a few places, but... We looked at this one. Looked at this one. It's still possible for this to just take all 5 on the row. I'd love to be able to say that this has to be odd. sorry, yeah, I could take these 5. That would put 5 odds here and make both of these even, which seems reasonable given the 8. So okay, if these two were odd, these two are even, these two are even. This 5 needs one more odd in it. There's not really any requirement on these two. It seems to work. This sees 2 odds. So it needs 3 more. I could even just take these 2. Yeah, it doesn't have a specific direction it has to go. That's what's so frustrating about this. Do I need to use these circles? I don't see how. They're not even limit, like they could be a 9. There's no reason they couldn't be. I haven't even proven that the odds have to pass through this center. Because if this 5 comes all the way across, then it could be the bridge between the left and right half. Or we could just bridge the left and right half this way. This 8 could even just be... Well, okay, if one of these is a 3, the 8 can get 7. Yeah, I could even just do that. That's not useful. I was trying to decide if it had to come out of this box, but it doesn't. Two's down here somewhere. Whoops, not 1, 2. I have these 3 2s, I have these 2 2s. Okay, so 2 is here somewhere. In this box, 2's one of these 3. I'm not sure how much this is helping, but I need to do something. Wouldn't it be interesting if one of these were a 1? 1 would be odd, which would put... So if this were odd... Oh, okay, so this can't be 1. I'm not sure how much that helps, but it's an interesting observation. Because if this were 1, it would have to be blocked on all 4 sides by an even number, and that would put 5 evens in the box. So this is higher than 1. Oh, and a 1 would self-isolate itself automatically. So it would have to be surrounded by evens, and then it would be blocked off. We'd break the rule of all odds being connected. So these aren't 1. But, I mean, anything else in the box can be 1, so still something useful to keep in mind. That's true. Like, if we grew a 3 like this, and then we had to block it off with evens, it could still escape. Okay. Is there a way I can draw it where it can't escape? I don't think so. This 5 needs one more, and only one more. 7 needs 3 more. Could take those, or could take those. Those? Or those? So I mean this is always odd. So if this 7 doesn't take this one, if this were blue, it needs 2 more odds, and it can't take this one to make an odd, because then it would have to then also take this one, and it would have too many. So it has to take this one. This one has to be odd. On the other hand, if this is odd, sorry, I think I said that wrong. I said that very wrong. I was saying it the other way around. So this has 4, so it needs 3 more. So it couldn't take this one. Oh no, sorry, it could take this one, but then it would still have to take this one, right? This cell. Or it could just not take this one, in which case it takes this one and this one. But either way, it took that cell. And then also, if this were odd, you'd think it could take this or this, but I've explained this twice now, but it couldn't take this one, because then it would only have 6, and it would still have to take that one, and then I would have 8. So no matter what, this 7 takes this as an odd, which makes this even, and this one odd. So that's progress. This is also a 1, 3, or 9. And this is a anything but 5. 1, 3, 7, 9. This is a 4, 6, or 8. This has to connect somewhere. I could still even just make both of these even though. And I could just come around somehow. Can I do that without isolating the 8? Oh, but this is connected up here. So this could just come all the way around like that. And then this one here can come down and around. So. Yeah, and this 5's connected to the 3. So that's not a problem at all. It just does that. Okay, well, I got this 2 done. That's nice. How about this 5? We still haven't actually figured out which of these 2 is odd. If these 2 were even, they'd be 6, 8. And so this would be a 4. These 3 would be odd, making that a 4. And that would be even. That's all fine. There's just so many ways to draw this. I'm amazed that there's a logical path here. Wow, it's already been like half an hour. Doesn't feel like it. Yeah, the only thing we have to avoid is making both of these even. One of them has to be odd. But I don't know what that means. If this one were odd, interestingly, this would have to be even. Actually, oh no, sorry, it's the seeing. Only one of these is odd, right? And only one of these is odd. Is that at all restrictive? So if I made these 2 even, this would have to connect up like that. I don't think that actually forces this to be anything in particular. I think I was saying at least one of these is odd, but they could both be odd. as well. So I think no matter how oh no, so if I made these two even, then these now can't connect to the 8, because these would have to be odd. But that's not actually problematic for the 8. Doesn't prove anything. How about this 4? Is it possible for this 4 to escape? Yeah. Could just zoom right out. This 2. One of these two is odd. One of these two is odd. Oh boy. I've gotten 1 digit. What am I not seeing here? I need 2 more evens in this box. So only 1 more odds left in this box. Yeah, and I think I already looked. If I put these as even, that doesn't actually prevent us from linking up. Something like that would work. But then this wouldn't be 5, interestingly. Yeah, okay. If both of these were even, how do we do this 5? We can't. We only can get to 4. So our last odd is one of these two, so this is even. Seems like such the smallest possible deduction, but it's a deduction nonetheless. Whichever one of these is odd, it's the only... Oh, okay. So if this one were odd, we'd get 1 more. Oh, I can't draw 4 odds like this, because then this 3 would be seeing 4 of them. So the maximum I can go down is 1 more, which means the 5 needs 2 more, at least. It could take 3 more, but it at least needs 2 more. But I think that's already proven by one of these being... Oh, shoot. It's proven by one of these being odd already. We know there's an odd and even left here. I guess that's kind of what I was already using to prove that this had to be even, but... Well, okay, so... If this were odd, this would have to be odd, I think is what I was trying to get at. It's similar to what this 7 was doing. So if this is odd, this one has to be odd. We can't take this one, because that would only make it 4. We can't take this one, so we'd have to take this one, making it 6. If this is even, then I have to take both of these. And that's not possible. Okay, so I just got 2 deductions. One is that this has to be odd, but also this has to be odd. And that finishes my 5, so this is even, and this is even. Okay, so this is 1, 3, or 9. That's a triple. This is the 7. This is 5. this column has all its odds, so that's both of those are even. Oops. So the 3 is now here. This is 6 or 8. This is 6 or 8. This is 4, 6, or 8. This 7 now. Oh, does that take too many? Oh no. My 7 now has 8 odds. Okay, where did I go wrong? This has to be even for the 7. So what's the problem here for this 5 then? The problem is the 5 has to do this, and now the 3 is broken. Oh no. Where was my bad deduction? Well, hold on. This doesn't have to be even. If this were odd, that makes this 7 large. Was I just miscounting? Was I like double counting the 7? Let's just go with this. So this is odd. 5 sees 4 now. This has to be even because of the box. And so now in order for the 5 to see one more, we're getting this again. And then this 7 isn't allowed to see any more. I think the only mistake I made was making this one odd. But, well, maybe not. Maybe 1, 2, 3, 4, 5, 6, 7. This has to be even. And that's true. We have all of our odds for the column. Maybe I just thought I made a mistake and didn't. Maybe I made a mistake about my mistake. So this is still 1, 3, 9. That puts the 7 here. Puts the 5 here. This isn't a 4. The 4 is here somewhere. This is 6, 8, and this is 6, 8. This is 1, 7, or 9. Okay, I think this is fine. Seven goes in one of these two. 5s, we got. 5 is one of these two. I need 2 more evens in this box, so there's at least 1 here, which means these can't both be even. Well, we knew that already, because we placed this even. Oh, this 5 needs 1 more. So that takes this one. And it can't take this one. So that box is filled. That actually puts a 3 here. This is 1, 9. So this is the 7. And this has to be even. That finishes our 2, so that has to be odd. This is 4, 6, or 8. I keep typing the wrong numbers, sorry. This is also 4, 6, or 8. What do we need? We need, for odds, we need a 1 and a 9. So this is 1, 4, 9, it looks like. Well, wait, hold on. We should need... This is 6 or 8. Oh, the 4 is... Why did I say the 4 is here? Ah, this can't be 4 because of the 4 in the row. So the 4 is here, so this isn't 4. That's a 6, 8 pair. There's a 4 in one of these two. This isn't 3. Let's just make sure we do our proper cleanup. All right. This odd has to get out. So that has to be odd, and that's even. So this is the 4. This is 1 or 9. That makes sense. Okay, that's good progress. What's next? we still could just do that for the 5. In fact, yeah, we could also, well, okay, how many more odds? We only get one more even. So only one side of this is getting blocked. So we're getting 1 or 2 more odds from this 5. Like, if the even were here, then the 5 is getting 2 more. The 5 is finishing, okay. If the even were here, then the 5 is getting 3 and it would have to go down 2. And if the even were here, then the 5 would be 4 and would have to come down 1. But that doesn't, all that tells me is this comes down 1 or 2 or 0. Which means this has to be even? No, it doesn't, because this could be, either of these could be even. One of these 3 is even. That doesn't mean much to me. Don't think so, at least. Let's find a different deduction. This 3 can't come right too. That's not meaning much to me. How about this 5? Yeah, the only way this 5, oh wait, this 5 sees 1 here and 2 here. So it actually needs 1 more. And there's only one way to get it. So this one's odd. And this can be a 1, 7, or 9. 3, it sees 3 and 5. This odd doesn't necessarily have to grow, because this can still connect up here. Or, I mean, this is all connected already, so it can just come around here. It feels like this 8 should take these, but it doesn't have to. 4s. Look into here. So one of these is a 4. So one of these is even. Interesting. I've got a lot of even numbers sort of culminating in this area. 2, 4, and 8. Oh no, 2 can be here as well. It doesn't mean much. We know at least one of them's even. Don't know which one. We already have 4 odds in this column. Oh, and we can't take another one. I didn't finish this logic. This one has to be even. So it's not a 3. It can be a 2, 4, or 6. We only get 1 more odd. This probably has to get out, but I mean, it probably does get out, but it doesn't have to get out. Like, we could block it off and then it just gets out up here or here. This needs 8, but it's still quite viable. Like, it's got so much empty space to grab 8s. 8 evens. Excuse me. Get some water. Sit up in my chair. We only get 1 more odd in this row. So at best, this 3 gets 1 odd from this row. It means it has to get its other odd from this row. From this column, I mean. So one of these is odd, at least, if not both. It's not enough to make a deduction from. I could even take these two, and this can still get out. If I took this one would be even. Yeah, I kind of said that. If I made these three even, I could still even do that and make that even. That odd. And everything could still even connect up. It feels really close to something. Oh, okay, this 3 has everything it can get. So this has to be even. Which is a 2, 4, or 6. Oh, not a 4, it's a 2 or 6. Let's use that 4. We have 3 evens. We get one more even, one more odd here. Oh, this 2 can't, this has to be odd. Okay. Interesting. So it does block off. This odd has to get out. This is 2, 4, or 6. This is 1, 3, 7, 9. It's not a 3, so it's 1, 7, or 9. This is not an 8 anymore, so the 8's one of these two. So at least one of these is even, and then we have one more even. This has to get out. So one of these two is odd, at least. Can't tell which one. Oh, wait. If this one were odd, no, this is fine. This is fine. We just do that. This would be even, but then it can come out this way. Oh no, we have all 5 odds. Yeah, that would isolate this. So let me go over that slower. So one of these two, let's put it this way. We only get one odd in this row. So let's say the odd were here. Yeah, let's say the odd were here. So that makes these 3 even. So now this 3, in order to not isolate, has to connect up here. But now this box has all 5 of its odds, so these two have to be even. And now this little hat-shaped area down here is not connected to the rest of the grid. It diagonally doesn't count. So that all was predicated on placing this as odd. So this is actually even. One of these two still has to be odd. This is 4, 6, or 8. Okay, what else can we do? We get one more even in this whole column. This 8 actually, it already has 5. So it only gets 3 more, but it must get 3 more. There's a lot of, so one of these 3 is even. Interesting. Oh wait, how much? Wait, it has 1, 2, 3, 4, 5, 6, 7. It has 7. I almost miscounted that. So it's got 7. It gets exactly one more, and it has to come from this column here. And that's going to be the last even, which makes these 2 odd. That feels important. This is also 1, 3, 7. And this is 1, 5, 7, 9. The 3 is here. Okay, so we get one more odd up here. I mean, this could still be even. Okay, is there more that I can see here? So if this one were even, that means that it has to be a number where it sees as many as its value, which actually means it can't be here. So if this were even, it's seeing 3 right now, which is an odd number. So it would have to see one more, which by definition would be orthogonally connected, making this region size 9, at least. So this is odd. Wow, that's really cool. Okay, what is the... I mean, this can see so many to its left, potentially. So it's already seeing 2, and it can see 3, 4, 5, 6, 7, 8. So this isn't a 9. So this is 3, 5, or 7. Let me just double check that. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And so 7 would be difficult, but doable, right? Let's see how we get... Oh, okay, so in this row, we can have 3 more odds, and in this column we can have 1 more odd. So 1, 2, 3, 4, 5, 6. So we can't actually be 7. Okay, so this has to see 4, but I mean it could just do that. I've seen that before. I mean, I've seen that logic earlier in this solve. That would force... Oh, actually it can't. If I wanted this to escape the box this way, then it would have to be fully surrounded by odds. And I mean, that puts way too many odds on the board. 6 odds in box 7 for 1. So is there any other way to get out? 1, 2, 3, 4. No, because in order to get out, it has to take the direct route. So all of the evens are connected to this 4, and they're all from this box. What does that mean? I mean, we could do this, we could do that. Two of them come from this row. And I don't think I can do it this way, because that leaves only 3 here. So that means this one has to be even. Ooh, what else does this mean? I can't take both of these for even. And I can't take none of them. So we have 3 evens already. So this one's odd, because I'm going to grow 1 more, either here or here, to make 4. So this one's odd. And that's a 1, 7, or 9? Yeah, looks right. Oh. But if we took this one as even, we know one of these 2 is the last even for the 4. It couldn't be this one, because that would isolate an odd. So it would have to be this one. Is that a problem? Makes these 2 odd. Makes this even and this odd. This has to be odd. And these 2 even. This is all fine. Shoot, I thought, in my mind, I thought I saw it isolating. Oh, it does isolate. That's quite the... Wait, that does... I think it's much simpler than that. Let me try that again. So if I take this one, I know I have to take one of these two, and there's no choice, because if I took this one, that immediately isolates an odd, right? So I have to take this one as an even. But now these two have to be odd, because the box has to have 5 odds in it, can only have 4 evens, which forces an even into this row, and now this 3 is isolated. So that all came from placing an even here. So this is odd. That means the even's one of these two. If the even were here, this has to be odd. That puts an even here, and that works. If the even were here, this has to be odd and this has to be even. That also works. Darn. Might as well mark this one as 1, 3, or 7. Oh, not a 3. One day I'll get a naked single from one of these. Let's see. Always hard to find naked singles, right? So let's look at the scenario where we take these, and then that has to be even, and that has to be even. So that's odd. That isolates this, because these have to be even. And now this is completely isolated. So, and that's the only option. We either take this one or this one. We obviously can't take both for many reasons. If we take this one, that is end of the line for this. Well, it's not end of the line for the blob, but if I take this one, I can't take this one. So, I mean, this is forced even. So now the only option to make it 5 is this. Wait, why would that be end of the line? I can just keep going. Oh, no, I can't, because that would make that more than 5. Oh, wait, so I could... Oh, but I have to take this one. Yeah, that logic is sound. So I'm not taking this one. I'm taking this one. This 5 is done. Those two are even. This one's also even. We now have 5 on this 8 blob. These are 4 and 6. This is 1, 3, and 7. It's not a 3. This is 6 and 8. This is 4, 6, or 8. We have all of our evens in this row now, so these are odd. These are 1, 7, can't be 9. So it's a 1, 7 pair. So this isn't 3. I think I've had this 3 for a bit. So this is a 3. Sorry for not seeing that. I don't know if you've been yelling at me about that one. We have all of our odds, so both of these are even. These are 2, 4, or 6. We don't have to get out this way. Like we could plug this and then it would just get out through here. Okay, so what does this tell us? We have 4 odds. So 2 of these are even. And we know that the 5's here. So this one has to be even because there's no more odd numbers left. We have 1, 3, 7, 9 taken. So this one's even. One of these is 5 and one of these is even. Got an even 5 pair. This is 2, 6, or 8, and this is not 8. Oh, this 1, 7 pair puts a 9 here, 1 here. This isn't 1. It's not 3 either, so that's a 9. Whoop, that's a 9. That's not 9, and that's not 9. Let's not forget our basic Sudoku. Fives. Seven's one of these. Did I get anything else here? How about this? Okay, this column we already knew. This row gets one more odd. Okay, we can't block off this. It needs 2 more evens and then it needs to be blocked. So one of these two is even, but that's true just from the row. At least one of these two is even. This could be odd. I mean, having this come out makes a lot of sense to me. So how do we do this 3? Actually, now that this is even, this 3 can't come down 2 because then it connects to the 5 and then it's more than 3. So this 3 at most can come down 1, which means it definitely has to take this one. So these two are even, and then we have to block that off so it doesn't grow larger than 8. Ooh, we're so close. 1, 2, 3, 4, 5. This is the 5, and this is even. This is a 2, 6, or 8. This one's a 1, 7, or 9. This one's not a 2. It's one of these two is a 2. We need 1 odd, 1 even here, and 1 odd, 1 even here. Ugh, what are they? We could still do even, odd, even. So we need to, this whole thing has to connect up with this area down here. And I know it's hard to see my highlights on the orange, but it can't actually connect this way. In fact, we know that this gets 1 more and then this is even. So maybe that's going to be easier to see. But so we have this whole blob down here, which might include something down here, right? And there's this entire blob up around all these other boxes that isn't already connected to it. So they have to connect up through here somehow. So I need to be careful not to isolate that. We have 1 even, 1 odd here, 1 even, 1 odd here. Oh, okay, so then this is odd. Oh, yeah, we have 4 evens here. So this is odd. So that connects this up. Oh, this has to be 5, so that comes down. So that, wait. Uh-oh. Oh, no. I need 2 evens here. So I know that this has to link up. So let's just read. Maybe it wasn't broken and I just confused myself again. Yeah. Shoot. Maybe. What was my logic here? This can't go down further. This is 6, 8. This is 3, or this is 1, 7. The 1, 3, 7 pair puts a 9 here. This is 1, 9. I'm sorry for redoing this. Oh man. Let me try to remember what my logic was here. Right, so this could connect either way. I don't want to just say, oh, it was this stuff, because I think I got it in 2 different ways. Oh, okay, so this row is done. These have to be odd. Oh, remind me what I did here. This is 4, 6, or 8. These are 4, 6. Don't need the corner marks anymore. The problem is when you undo back to here, you forget what your train of thought was at the time. There was definitely something up here. Okay, what are these? These are, oh, well, this isn't, right, I got this 3. And that has to grow down. So this is 1, 7. So these 2 have to be even. Okay, so now we're in this scenario again, where this 3 can only take 1 more to the right. But it can't take 2 down. So there's only one configuration for it, which is these 2. So we're going to do that. We're going to make these 2 even. This is 8 now, so it can't grow anymore. So these 2 are odd. This one's even. That forces the 5 here. This is all looking very familiar. This has to be even. This 5 can't grow down 2. So now it must grow 1 to the right. That makes this even and this odd and this even. This is looking okay. Okay, I think I was actually fine last time and I just didn't see that possibility, which is, that's terrible, but that's how it goes sometimes. One of these is even, one's odd. Does it? Let's see, I have all my odds here. So this is even, this is odd. This is even because of the column. So this one has to be odd so we don't isolate the 3. So now this is even, this is odd. Okay, we have all our parities now. So it should be easy, right? This is 1, 7, 9. This isn't 7. This isn't 2. This isn't 2. So the 2's here. So that actually places our 2 here. Wait. Yeah, this can't be 2 anymore because of these 2's pointing up. So this is a 2. Why isn't this 2? Oh, because that one. Okay. So that's a 2. I'm getting paranoid because I don't want to back up again. This is a 4 or a 6. It sees 4. I mean, that's just what it is. What does this one see? 1, 2, 3, 4, 5. Yeah, easy. So that's the 3. Oh, I really hope this works. Okay, so this is not 5, so this is the 5. This is a 1, 7, or 9. This is also a 1, 7, or 9. I feel like the odds and evens are just going to be 2 separate puzzles at this point. Do I have any, I mean, all of my circles are done. So this should just solve itself at this point. This is 1, 7, or 9. This isn't 7. Oops. Just this one isn't 7. This 3 C's up here, so this is 3. What am I missing? Ah, this isn't 3, so this is the 3. Are my 3's done? 3, 3, 3, 3, 3, 3, 3. Yeah, 3's are done. How about 5's? 5's are also done. How about 7's? 7's down here somewhere. 7's up here. Maybe not 7's yet. How about 9's? Maybe I do the evens and then with fresh eyes I take a look at the odds again. Okay, so 4 has to go here. This is a 6, 8. This is an 8, 6, 8, 2. This is a 4 or a 6. So this is 2, 8, and this is 2, 8. Also 2, 8. This is 6 or 8. This is a 2. Make it single. 8, 6, 8, 2. 2 here. And this is 8. So this is a 4, 6. The 6 stays here. So this is 4, 6, 4, 6, 4, 6, 8, 6, 6, 4, 6. All right, that's the evens. Now I have to do the odds. All right, so I'm going to highlight in a different color where ones can go. See if that, actually ones can go anywhere? One's not a good choice. Do I not have any ones? I mean, I have this one. Okay, we're gonna have to do, let's do 7's instead. So these are 7. These are 7. These are 7. So this is an X-wing on 7's here. In row 4 and row 9. Yeah, this is just box logic. Well, it's not quite box logic. We can do box line reduction here, and then hidden single is probably the best way to put that. But it's also kind of an X-wing. So these two can't be 7 because the 7's have to be here or here in the rows. That makes a 1-9 pair. That puts a 7 here and a 1 here. So I am going to uncolor these. I'll make them orange again. Did that actually not finish me off? Okay, 7's are here. 7's are... All right, what about 9's? Or maybe we have a Y-wing now. Oh, might as well highlight 9's. See what it gives us. Did I miss any? No. I'm not seeing any. Not seeing any good patterns on 9s. I'm sorry if you do see it. That orange again. So I did not expect the end of this to be so sticky. This has been a difficult puzzle for me. I'm just gonna have to try something. See where that takes me. Maybe it'll reveal a interesting piece of logic to use. Okay. I may have to just say this can't be a 1. So 1, 7, 9. Puts a 1 in both of these. 9 here. 7 here, and then what's here? So is this a... Okay, I think this video is long enough, but I'm just trying to see if I spot any, like... This isn't a Y-wing, unfortunately. One, 7. It's like the interaction of putting a 1 here forces a 1 here through these guys. We go 1, 7, 9, 1. So that puts a 9 here. So 1 here puts a 1 here, which puts a 9 here. The 1 here unravels this triple and puts a 9 here, and then now we have 2 9s in row 5. And I have no idea if there's a better structure to see, but that's what I'm going to go with. So this is a 9. This is not 9. This is 9. 1, 9, 7. And okay, and that solves it. Oops. That's all. Whoa. Wait a minute. Oh no. I appear to be broken either way. Maybe that's the issue I'm having. Let me just do that again slowly. So 9 makes a 1, 7 pair. That puts a 9 here. 1. That puts a 7, 1, 7, 1, 7. This is, I think I made a mistake last time. This seems to work. 917971191. And there we go. Puzzle solved. Easy. No, not easy. That was really interesting. Please let me know if you see a better pattern, especially for the end there, or if there was some logic that made this a lot easier that I was just missing. But yeah, that was a fun puzzle. I didn't expect it to take me this long, but it was good. I enjoyed myself. I think if I had made certain mistakes, actually there were two places where I thought I made a mistake, but I actually just wasn't seeing the appropriate logic to continue. And so I undid it and then I redid that logic, and that just ate up a bunch of time for no reason. Because both times I realized, oh, actually it was fine and I could just continue this way. So yeah, let's just go through each of the rules that fpuzzles doesn't check just to make sure everything's good, because I definitely made mistakes here. So obviously regular Sudoku rules, fpuzzles telling us we're good there. All odd numbers lie in a single orthogonally connected region. So you can see that the orange region, there's no isolated bits. It's all connected orthogonally. So that's good. A number in the circle indicates the total count of cells of the same parity connected vertically or horizontally. So let's just go through the circles. This 5 sees 5 this way. It includes itself. This 5 sees 5 there. This 7 sees 1, 2, 3, 4, 5, 6, wait, 1, 2, 3, 4, 5, 6, 7. I almost double counted that 7 again and freaked out. That was one of my first mistakes. This 5 sees 1, 2, 3, 4, 5. This 5 sees 1, 2, 3, 4, 5. This 3 sees 3. This 3 sees 3. This 5 sees 5. This 3 sees 3. This 5 sees 5. I think that was all of them. And then we have 2 on this diamond. Yeah, diamonds show the number of orthogonally connected even numbers, including itself. So that's 2 evens. That's 4 evens. This is 8 evens. This is 4 evens. This is 2 evens. And I never actually checked this one. 1, 2, 3, 4, 5. It worked out. So that's 8 evens. All right. So I hope you enjoyed this puzzle. I know this was a long video. Editor David's going to have the time of his life figuring out how to fast forward parts so we don't end up with a 2-hour-long YouTube video. But either way, I hope you enjoyed it, and I hope you enjoyed trying to solve this yourself. And if you want to see more live solves, more and other Sudoku type content, it's good to subscribe so that you can always see in your feed when those videos show up. And if you click the bell, then you'll get notifications when I post the video, which can be useful as well. And other than that, thanks for watching.